Hello, my name is Francesco Turco. I'm a technical advisor here with F.A.S.T, and today we're going to spend some time looking at unconventional tests in WellTest. Now, F.A.S.T WellTest is an advanced pressure transient analysis program that allows the user to interpret reservoir flow characteristics and to forecast future production based on these analysis results. Now, along with conventional drawdown and buildup tests available in WellTest, we also have a variety of unconventional test types to choose from. Slug injection, closed chamber inflow, and closed chamber injection, primarily used for offshore DST analysis. MiniFrack and perforation inflow and injection, or PIDA analysis, used for fracture diagnostic analysis. Now, in reservoirs where conventional drawdown buildup tests require long-term shut-ins, such as in shales or tight gas, unconventional testing provides reliable estimates for key reservoir parameters from data normally used solely for fracture treatment design. Now, a MiniFrack test is an injection fall-off diagnostic test performed without proppant before a main fracture stimulation treatment. The intent is to break down the formation and create a short fracture during the injection period, typically 5 to 15 minutes in duration. The created fracture cuts through any near wellbore damage and provides better communication between the wellbore and true formation. The pressure fall-off data are then analyzed using specialized techniques to yield formation leak-off characteristics, fluid leak-off coefficient, fluid efficiency, instantaneous shut-in pressure, fracture gradient, fracture closure pressure, formation permeability, and reservoir pressure. Let's take a look now at a MiniFrack example. We have here our G-function plot, and by looking for the departure from the straight line, we can get our G time, closure time, and fracture closure pressure. We can also take a look at any flow regimes we've seen after closure. In this case, we see a well-defined radial flow period after closure. Once we've identified our closure time and pressure and any flow regimes, we can go and use that information to create a model of the system. We've populated our model with the initial parameter estimates we got from our pre-closure analysis, and now we're going to use the automatic parameter estimation tool to fine-tune that model. Now, once we've achieved a good model of the reservoir, we can use this model to do forecasting and design any future testing. So what I have here is I've set the flowing pressure to 1000 psi, and I've looked at two different scenarios, one with a positive skin and one with a negative skin, to see how cleaning up or stimulation of the wellbore could improve performance. So we can see how we get much more cumulative production and a much slower drawdown with that negative skin. Now, once we have our initial estimates and our model for our original reservoir, we can use those parameters to come up with any other types of designs or models or reservoirs that we'd like to test. For example, I've taken our reservoir parameters and made a horizontal well. We can take that horizontal well and we can apply that same forecast to see how a skin of 5 or a skin of -3 will affect it. And now we have the ability to also go in and copy these to a comparison plot. So we can quickly look at different scenarios, one for a horizontal well, one for a vertical well in the same formation, with and without stimulation. And we can make decisions based on this information. So what are the benefits of unconventional tests? Pre-frac injection tests are often performed by frac companies in order to determine critical frac parameters before the main stimulation. The same data can also be used with unconventional test analysis to provide critical reservoir parameter estimates for formation permeability and reservoir pressure. And these parameter estimates can be used to develop a reservoir model, which can then be used to forecast production for multiple completion or operating strategies, and also to create any sort of what-if scenarios, such as the one we created to see what if we drilled a horizontal well instead of a vertical well. If you have any more questions regarding unconventional tests, please contact us at F.A.S.T.com. Thank you.